Find the equivalent resistance of the network shown in the figure between the 2 points A and B. In this case, we can draw the diagram again and we can denote the resistances as R1 equal 8 ohm, R2 equal 8 ohm, R3 equal 4 ohm, and they are connected by this type of conducting wires or connecting wires, and R4 is equal to the fourth resistance is will be what? 12 ohm. Fourth resistance will be 12 ohm. This is the fourth resistance, which is equal to 12 ohm. And we have to find the equivalent resistance between the 2 points A and B. That means RAB equal question mark. After this, we can draw the modified diagram of the given circular shaped network. In this case, if we pull the terminals A and B on the, towards left and right, then we get this type of modification of the given network. This type of modification of given network, and this diagram, the second diagram, is equivalent diagram of the given network. So these are the two terminals. A and B are the terminals, and four resistances, that means R1, R2, R3 and R4 are connected in this way. In this case, what R4 and R1 are connected by using a connecting wire. We can draw another modified circuit diagram of the given network. R1 and R2 are connected in parallel combination, and R3 is connected in series combination with the parallel combination of R1 and R2. And finally, the fourth resistance, that is R4, will be connected in parallel combination with the series combination of R1, R2 and R3. So if we compare these two circuit diagrams, so the resistance R1 is connected between the two terminals A and C. Similarly, in that diagram, R1 is connected between the 2 points A and C. Again, the resistance in the first diagram, this is the point D, and the resistance R2 is connected between the 2 points C and D. The resistance R2 is connected between the 2 points C and D in the given diagram or in the second diagram. Similarly, in the modified diagram, R2 is also connected between the 2 points D and C. We can denote the point B in the modified circuit diagram. The fourth resistance R4 is connected between the 2 points D and B. Here also in the modified diagram, we can show that the fourth resistance R4 is connected between the 2 points D and B, and this is the second diagram. And here again we can draw the diagram, that is R1 and R2 are connected between the 2 points D and C, Two resistances R1 and R2 are connected in parallel combination between the 2 points D and C. The third resistance R3 is connected in series combination with the parallel combination of R1 and R2, and the fourth resistance will be connected in parallel combination between the 2 points D and B. This is the fourth resistance, which is R4. R4 is connected in parallel combination with the whole combination between the 2 points D and B. Between the 2 points D and B, the fourth resistance R4 is connected. Between these two terminals D and B, R4 is connected. And between the two terminals C and D, two resistances R1 and R2 are connected. Between C and D, two resistances R1 and R2 are connected in parallel combination. and between the two points C and B, the third resistance R3 is connected. Between the 2 points C and B, the third resistance R3 is connected. So this is the modified diagram, and also we can draw another modified diagram, that is equivalent resistance of the parallel combination of R1 and R2 is denoted by Rp, and between C and B, third resistance R3 is connected, and between the two terminals D and B, fourth resistance R4 is connected in parallel combination. R4 is connected between the 2 points D and B. Now Rp equal R1 dot R2 divided by R1 plus R2. R1 dot R2 divided by R1 plus R2. So we get, if we put the value, then R1 is 8. 8 into 8 divided by 8 plus 8, that should be what, 4 ohm. We get the equivalent resistance of the parallel combination of R1 and R2 as Rp, which is equal to 4 ohm. Now in place of Rp and R3, we can write Rs, and we have to denote R4 again. The equivalent resistance Rp and R3 are connected in series combination between the 2 points D and B. So Rs is equal to Rp plus R3, that is 4 plus 4. So we get Rs, which will be equal to 8 ohm. Rs is the equivalent resistance of the series combination of Rp and R3. Now Rab equal Rs into R4 divided by Rs plus R4, putting the values 8 into 12 divided by 8 plus 12, that is 96 by 20. 96 divided by 20 ohm. So finally we get Rab as equal 48 by 10. Therefore Rab equal 4.8 ohm. Rab equal 4.8 ohm. That is the equivalent resistance between the two terminals A and B. Now numerical number 16, a circular ring having negligible resistance is used to connect 4 resistors of resistances 6R, 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 6R as shown in the figure. Find the equivalent resistance. Find the equivalent resistance between the 2 points A and B in the diagram. Equivalent resistance between A and B in the diagram. Now we can draw the diagram again. So these are the 4 resistances which are connected as shown in the figure. There are 4 resistances which are connected in this way. Here 6R, 6R and 6R. These are the 3 resistances. Then 4th resistance is capital R, that is connected between the junction and the point B. Now we can connect connecting wires between these points as shown in the figure. We can connect connecting wires between the points as shown in figure, and this connecting wire will not touch the terminal B. Now we can we can draw the modified circuit diagram of the given circuit diagram. In this case, first three resistances will be connected in here. The first 3 resistances are R1, R2, R3. They are equal to 6R, and 4th resistance is R4. The first 3 resistances, that is R1, R2, R3, are connected in parallel combination, and the 4th resistance R4, which is equal to R, will be connected in series combination with the parallel combination of the first 3 resistances. Now we can denote different points, that is F, D and C. These are the points F and D and C, and we can connect R4 between the 2 points C and B. And these are the 3 resistances, that is 3 resistances which are connected between the 2 points D and C, or F and C, or A and C are R1, R2 and R3. First 3 resistances are connected between the 2 points A, either between A and C. R1 is connected, between A and C, R1 is connected, and the second resistance R2 is connected between D and C. Similarly, in the following diagram, R2 is connected between the 2 points D and C, and R4 is connected between the 2 points C and B. This is the modified circuit diagram and here after that we can draw another modified circuit diagram. Between the 2 points A and B, there should be two resistance only, RP and R4. RP and R4. RP is the equivalent resistance of three resistances, that is RP equal to R1 dot R2 dot R3 divided by R1 R2 plus R1 R3 plus R2 R3. Now R1 equal R2 equal R3 equal 6R. Therefore, it will be R1 by 3 equal 6R by 3. Therefore, RP is equal to R. Equivalent resistance between the 2 points D and C, or F and C, or A and C is 2R. Now we can find the equivalent resistance between the 2 points A and B, which is R1 plus RP. R1 plus RP, that is what you know, that is 2R plus R, or R plus 2R. So we get the equivalent resistance between the 2 points A and B as 3R. So RAB equal 3R, which is the equivalent resistance between the 2 points A and B. Between them there are 4 resistances. First 3 resistances is connected in parallel combination, and the fourth resistance is connected in series combination.